Hello everybody, today we will be starting with chapter number 1 of Algebra, that is linear equation in two variables. So what do you mean by linear equation in two variables? We've already seen in 9th standard about it. This is like having two variables, like say x and y are two variables, constants are a, b, c. The standard form of the linear equation in two variables is ax plus by plus c equal to 0. Here, when we say linear equation, it means that the variable is having a degree of 1. When we not specifying it, that means it is 1. What is then not a linear equation is when the degree comes to 2 or more than that. For example, if I write x square, here the degree is 2. Or if I write x, y as two variables, but here the degree is 1 plus 1, that is 2. So again, these are not the examples of linear equation, whereas these are the examples of quadratic, where the index is 2. So now we are not going to deal with these equations in linear equation. Now what do you mean by two variables is we are going to have two variables x and y. Now I want to know how many solutions can we have for a linear equation in two variables. So here if you see, last time also I told you, here we have simultaneously infinite number of solutions. For example, let me write this in a form ax plus by equal to say minus c. Or for example, I take something else, 2x plus y equal to say 3. Here, how many possible, or let's take a simple example, x plus y is equal to 3. How many possible values of x and y will give us the answer as 3? Here, if I substitute for x as 1, what is going to be the value of y? Y is going to be here 2. So 1 plus 2 answer gives me 3. Here I can have x value as say 2. Y value is 1. X value can be minus 1. Y value will be what? Minus 1 will be 4. That way we can have infinite number of x and y values to satisfy this given equation. Now what do you mean by linear equation in two variables and simultaneous equations? Simultaneous equations means two simultaneous equations such a way that satisfies both the equations. This is say one equation. I take another equation wherein x minus y is equal to say 1. When I want to solve these two equations at the same time, we have just one and only one solution. Like if I represent this in form of a graph, let me represent this in the form of a graph. What is this going to be? X is 1, y is 2. X is say 1, y is say 2. So this is going to give me this value. X is 2, y is 1. X is say 2, y is say 1. Then x is minus 1. When x is minus 1, y is 4. So this is going to be that. So if I am going to draw a graphical representation of this one, this is going to be that equation, x plus y is equal to 3. Right? So linear equation can be represented in on a graph this way. So now I am going to even plot the graph for x minus y equal to 1. So given any value of x and y, let me take x value say 4, y value say will be coming as 3 because 4 minus 3 is equal to 1. If I take this as 3, if I take this as 2, 3 minus 2 equal to 1. That way I have infinite number of values against x and y to give me the answer as 1. Let me plot this and see what happens. Okay. So now when x is 4, x is 4, x is 4, y is 3. X is 3, y is 2. X is 2, y is 1. Okay, so it's going to go through this point. Now this is going to be equation x minus y is equal to 1. Now what do you mean by solution of two simultaneous equations? Solution means that point which is common for both the equations. Like this line and this line, which is that common point which is for both the lines. So this is that point which satisfies both of the equations. That is x is equal to 2 and y is equal to 1. This is nothing but the solution of two simultaneous equations. But this is graphical way of representing the two simultaneous simultaneous equations. Every time it is not possible for us to solve a given simultaneous equations graphically. So there is another method which is algebraic way of solving the same equations, which we will see in the next class. As of now, we will just revise the concepts related to 9th standard that we did of solving the two given equations with elimination method and substitution method. I just wanted to know, what do you mean by this method? These methods are meant to find the solution like this. It is meant to find the solution like this. By graph I can find it like this, but every time, if suppose a value comes in a fraction, if the value comes in a fraction like, x value is 3/9, how am I going to be so precise on a graph? I cannot be so precise on the graph. And that's why algebraic way of solving the solution is also should be known to us. Okay? Start with elimination method, which we have already seen in 9th standard. Here what is elimination? Elimination means out of the two variables, we need to get rid of one variable. Once we get rid of one variable, we just are left with one, and then it becomes a linear equation in just one variable, right? So here, how can we eliminate one of the two variables? Here x is having a coefficient of 1, y is having a coefficient of 7. X is having a coefficient of 3, y is having a coefficient of -1. Let me name this as equation 1 and 2. Now, by what means can we eliminate x or y? Let me think. If I multiply this equation by say 3, right? If I multiply equation 1 by 3, what is going to happen to this equation? Let's see. It's going to be 3x, correct? Plus 7 3s are 21y is equal to 10 3s are 30. So now equation 1 has become, let me name this as equation 3. Now what I see, equation 2 and 3, the variables are the same here and the coefficients are same. So what do I do? What operation do I perform so that I get rid of one of these variables? Like x I want to get rid of. I'm going to subtract it. As soon as I subtract, the sign changes. So now it's going to be 3x minus 3x, which cancelled. Here I get minus 2y minus 21y. This minus 23y. And what is it? Minus 30 plus 7. What is it? Minus 23. Right? So what is y is equal to minus 23? This thing will come down. It's going to be minus 23. So y is equal to 1. In this step, what did we see? When I multiplied equation 1 by 3, I made these two coefficients same. After making the two coefficients same, I could subtract it, and now here if you see in equation 4, I have completely got rid of the variable x, and now I am able to find the value of y, and y has come out to be 1. Now is it easier for me to get the value of x? Yes, it is. By substituting y equal to 1 in any of these equations, either 1 or 2, you can substitute and get the value of x. Which is easier equation? I think equation 1 is easier to get the value of x. So, or what I am going to do, I am going to substitute. Substitute y equal to 1 in equation 1. Right? So, it's going to be x plus 7 into y is 1 equal to 10. So, x plus 7 is equal to 10. So, x is equal to 10 plus 7 becomes minus 7 on the other side. X is equal to 3. So, I got the answer as x equal to 3 and y is equal to 1. Same thing we could have done by graphical method, which I showed by finding three different coefficient values for x and y and simultaneously solving them. So now what is this? Nothing but the solution of the given two simultaneous equation is x equal to 3 and y is equal to 1. So this is how we solve the questions by elimination method. We are going to look at another method that is called as substitution method to solve simultaneous equations in two variables. This also we have already done in 9th standard. Here we again have the same equations that we took for elimination method. Now what do you mean by substitute? Substitution means substitute for subtract one value into another one. For example, here, let me take equation 1. From this, can I write x in terms of y? It is possible. So what I'll do is x is equal to, let me take variable y on the other side. So 10 remains on the same side and plus 7y, when it comes on the other side it becomes minus 7y. Let me name this as equation 3. Now I can substitute for the value of x into second equation because we have derived this equation from equation 1. So we don't have to substitute back in 1. We have to substitute in the other equation. So when I substitute this value of x in second equation, what am I going to get? Instead of x, I have to write 10 minus 7y minus 2y equal to 7. So what am I doing? I am substituting equation 3 in equation 2. So that gives me this equation. Now let's open the bracket. 7 3s are 21y minus 2y equal to 7. Now this one you very well know how to solve a linear equation in one variable. The variable here is y. So here is going to be 30 minus 21 minus 2. You know how to do this one? Minus 21 minus 2. Same sign, keep the same sign and add the numbers. So it's going to be minus 23y is equal to 7. Minus 23y, I take it on the other side, so it becomes plus 23y. 7, I will take it on this side, or constants on one side and variable on the other side. So this becomes 30 minus 7, which is 23. Into 23 becomes upon 23. So what do I get the value of y as? 1. So why is this called as a substitution method? Because we have substituted the value of the variable x into another equation. So this is why it is called as a substitution method. Okay. After you get the value of variable y, it is the same as solving the equation with elimination method, right? So I am not going to show you that you already seen in the earlier method. So this way you can solve with substitution method. Thank you. We are going to do special case of solving simultaneous equations. This is one example that I am taking. Here if you see, the special case is when x and y coefficients are interchanged. Like x coefficient is 49, here y coefficient is 49. Here y coefficient in the equation 1 is 57 and x coefficient here in equation 2 is 57. So these coefficients are interchanged. This is a special case that we are going to consider. How do you solve this question? So here there is a simple way of doing it. First you add the two equations, then you subtract the two equations. You are going to first add the two equations. When you add the two equations, what is the addition of 49 plus 57? It is 106x, right? And when you are going to add these two, minus 57 minus 49, it's minus 106y. And the addition of these two is going to be 424. Can we simplify this further? Is it divisible by 106 by any means? Let us see. 106 divided 106 divided 106. So this one, if I divide throughout by 106, what am I getting? This one's are, this four's are. So it is left with x minus y equal to 4. This has turned out to be a very simple equation. Let me name this as 3. Now this is special case when coefficients are interchanged, so we are adding the 2. Now we are going to subtract these 2. So it will be 49x minus 57y is equal to 172. I think this number I will take it up. Let me take this as 57x. You could take it down also, there is no problem. 47y is equal to 252. So I just got these two equations down. First we perform addition, now we are going to perform subtraction. So how much is that? 8x minus, when I subtract it is minus, this one comes plus this one turns minus. So how much is it coming up? Plus 8y is equal to 0, 80. Correct? So let me, now is it divisible by 8? Looks like. So let's divide this by 8. So the answer is x plus y is equal to 10. So this was equation 3. I got equation 4. Now these are two simple linear equations in two variables where x minus y is 4, x plus y is 10. So you know how to solve these two further, right? So x plus y is 10, x minus y is 4. So just I wrote this equation 4, equation 3 as is. Now can I add the 2 again? So if I add this 2, I am going to get 2x. This gets cancelled, is equal to 14. So x is equal to 7. Then I can substitute the value of x equal to 7 in 1 or 2 or 3 or 4. But what do you think is the most easiest of all? I find equation 4 to be the most easiest of all. So let me substitute x value in equation 4. Okay, so x value is 7 plus y equal to 10. So y is equal to 10 minus 7, which is 3. So what is the solution of these two simultaneous equations? The solution is x equal to 7 and y is equal